Hello, I'll be starting the webinar here at about 2:30. Thanks to all who've joined me so far, and hope you enjoy it once I begin. All right, so it's about 2:30 here, and I'll be getting started. So my name's Adam Gill. I am currently a meteorologist at the National Weather Service in Binghamton, but formerly I worked at the Mount Washington Observatory for a few years, and I got to experience some of the weather that occurs up there, and I want to share some of that experiences with the people attending here today. All right, so Mount Washington Observatory, to start, let's see here, there we go. So let's begin with what is the Mount Washington Observatory? So it is located on top of Mount Washington, north central New Hampshire. It is a nonprofit research organization, so it is standalone. So we do work with the National Weather Service with our weather observations and our resident to help increase the amount of data that is acquired in central New Hampshire. We've been in operation since 1932, and it's currently one of the few mountaintop weather stations in the world that is staffed 24/7. It has one of the longest unbroken climate records of any station, and kind of what we mean by that is we still do weather observations the same way that we started them in 1932 using handheld instrumentation along with modern digital instrumentation. So actually, when I was there, we have two congruent climate records, one that is digital and one that is still manual. It is the highest point in the Northeast at 6,288 feet and is known as the world's worst observed weather. And the reason that we put in observed is largely because there is most likely some location in the world that does experience worse weather, but it's just not observed. And also we have some scientific backing as to why we have the world's worst weather, with the combination of the extreme of the high winds, the cold, and the snow, combining those all together, and then ranking each climate station based off of snowfall, temperature, and wind. A lot of times we end up at the top of that list each year. So we're located in the Sherman Adams building on the summit of Mount Washington. So the observatory is actually located in this tiny corner of the building on the summit. We occupy about 3,000 square feet when you live there, and it has the instrument tower, and then on the main floor is the office space, and then down in the basement of the building was the living quarters. The rest of the summit was the New Hampshire State Park. So this area of the building was open to the public, and if you visit the summit, they'll be able to go in this area, and there's a snacks you can buy, and but the location where the observatory is off limits to the public because it is where we live. So, but that always stopped people from walking in sometimes. They had some intruders on a pretty regular basis. So here's what our office space looks like. It's pretty general. We have a couple of workstations, and this is the only picture I actually have of inside the office. I'm not sure what was going on. I was back doing my internship back in 2015, but it's pretty general. This is our weather wall. So this is all of our instrumentation that we have on the summit, and it just puts it all in a nice location for visuals that we can look at all the data and record it. So to see what everything is, we have our high-speed wind chart, which has a calibration for 50 to 285 mile-an-hour winds, our moderate wind chart, which is 15 to 140 mile-an-hour winds, and our two paper barographs that we still used, our digital barometer, which is a bit more modern, and we also still had a mercury barometer and spiromercury thermometers, which we still every 4 days would use a mercury thermometer to check our calibration of our barographs. So we still use a lot of old school instruments. So like I said, we still did things like we originally did in the 1930s, as well as also using more digital instrumentation. Heading down to our living quarters, this is our living room. I picked this scene since it's Christmassy and festive, but it's pretty, we have a TV, books, lots of books in the background there, along with a lot of DVDs too for watching movies. We didn't really have access to general TV programming, but with the internet, with the modern age, we can have Netflix and whatnot. So we did have some modern conveniences. And then moving on into the kitchen. So that's a couple of our volunteers that we had when I was up there. They would help out with cooking dinner in the evening and come up for our shifts. And then our bunk room, since we lived and work up there, that's kind of like what the bunk rooms look like. Each bunk room had 3 to 4 beds in it, and we had 5 bunk rooms total and could sleep up to 17 people in our living quarters. So it got really packed, given that it was a really tiny area. We had all 17 people up on the summit at once. And then heading to our staff, we had 2 rotating crews that worked a week on, week off schedule, Wednesday to Wednesday. So that's the last staff picture I participated in before I moved to Binghamton here. So in the back row, we have Tom Padham, who is an education observer, then me, and then Jay, who was an observer, and AJ, Ian, Ryan, and Becca. So Becca was our summit operations manager. So she didn't stay on the summit all the time, but the six other of us did. And so the positions that we had were staff meteorologist, IT specialist, and then those are the times 5 p.m. to 5 a.m. for the staff meteorologist, then the IT specialist and education specialist are both day shifts, so 5 a.m. to 5 p.m. And then when we had interns on the summit, they worked 6 a.m. to 6 p.m. And then, of course, Marty the cat, who's probably the most famous being on the summit, since people are always intrigued by a cat living on the summit. So overall, what we did is we took hourly weather observations. All of us had to become METAR certified. And we actually still recorded observations on pen and paper. And so that is what the top picture is there, and we have all of our paper copies all the way back to 1935 sitting in drawers in the weather room. And my intern project when I was doing my internship there was actually to digitize as much of this as we can. And it took 10 years of full-time interns to be able to complete that task. And we also do have real-time weather data. So let me pull this up here. So currently on the summit, it's 32 degrees, getting wind gusts all the way up to 81 miles an hour. That was as of 2:35 p.m. So it's pretty gusty with the winds going basically from 0 all the way to 80. So I still check this page on a pretty regular basis and can see the winds ramping up. So it must be a storm coming in here with 0.2 inches of snow so far today. All right, so since we're not always doing weather observations, since it only took about 5 to 10 minutes per hour, we still have the rest of the hour to work on other tasks. So this is what the instruments that we use still. So down in the corner here, we have our sling psychrometer, which up there in the corner is me using it to record the temperature and relative humidity. So you swing that around and for about 5 minutes or so until down in the corner you have a dry bulb, which is a regular mercury thermometer, and a wet bulb that has a wick on it. And the difference between the temperature of evaporation and the ambient air temperature is how we got our temperature and relative humidity. Then our paper barograph would just trace the pressure over time along with the inches of mercury. So we use that for our hourly observations. And then we have our wind chart up in the middle. So we recorded winds on a paper chart that would rotate around for 24 hours, and that would plot what the winds look like for the day. And then other things that we did is each of us specialized in a task. So the staff meteorologist was the main forecaster, as well as data quality control, by making sure that all the information we recorded between our paper copy and our digital copies are the same. So that way we don't have discrepancies between the two data sets. Our education specialist, where they would teach distance learning. So there's Tom down there. He's teaching a class remotely to local schools and even as far away as Australia. And then IT specialist usually helps with the coding and instrument maintenance and installation. And then interns just help out with daily tasks, really. So this is a very common question we had in the summertime. It's just be like, oh, my weather station in the backyard records all the information that you do. So why do we have to be staffed when it can be automated? Because we're only open during the summertime to the public. The weather is very tranquil relative to the rest of the year. So it's an easy thing. It would be an easy thing to do if the weather stayed the way it did in the summer. But of course, winter is completely different. And so far in our time there with all the product testing, we have not had a digital instrument survive the winter without any sort of maintenance. So in the summertime, it's pretty tranquil. The highest temperature is, the average temperature is only 47.4 degrees. So we basically just have more of an extended spring that just jumps into fall, and then we go right back into winter pretty quick. The average wind speed in the summertime is 25.7 miles an hour. We get about 25.49 inches of rainfall in the summer, and then we average 1.1 inches of snow. Typically that falls in June, but also August is when we start to see our first snowfall of the year. So we're either going to get snow in mid to early June or mid to late August. So July is the only month I was on the summit for in which I didn't see snowfall. And then our seasonal extremes, our highest temperature ever recorded was 72 degrees, and our lowest temperature was 8 degrees. So you never really quite escape the freezing cold temperatures, even in the summertime, with the snowiest month being 5.1. The highest wind we saw was 154 miles an hour in July 1996. And actually this year we set a new August record at 147, which beat the previous 142 miles an hour when the tropical storm Isaias passed west of the summit. And then kind of jumping into pictures for the summertime, we did get a period of greenery where the grass was green and the flowers bloomed. A lot of times if it was a quiet day, we would get out for hiking. So the other person on the day shift would take over the weather observations, and the other person would take like the afternoon off and go out for hikes. It was really unique. A lot of times you'd have many layers of clouds both below and above the summit. So it was just really cool to be able to walk around and actually enjoy the outside before winter comes along, where you're going to be stuck inside for most of the period. We also had a lot of optical phenomena in the summertime. Had a lot of low fog develop in the morning times, and when the sun rose, it would cast your shadow. If you're on top of the tower, it would cast a shadow into the clouds below and create a Brocken specter, which is pretty common during the early morning or the evenings with low stratostatics. And of course, undercast. A lot of times, since we're very prominent peak, we are above the clouds on a pretty regular basis. So many times a week, we'll be above the clouds and get to look out down at a sea of clouds during sunrise. Then I have a time lapse here that I took back when I worked nights. So the unique thing about this day was that we were going in and out of the clouds on a pretty regular basis. And when you're in the clouds, we had an east wind, but above the clouds, we had a northwest wind, so almost 180-degree wind shift, which made for really cool fluid dynamics, where you have Kelvin-Helmholtz waves developing and then dissipating, and then it just really shows how fluid the atmosphere is. This was my favorite sunrise time lapse that I took. It's just cool to see the cooler, denser air from the east spilling into some of the ravines there, and the winds coming in over the top of it, creating those waves that you see and undulations in the clouds. And then probably the most exciting weather that we got to see in the summertime were thunderstorms. So these would develop usually on the summit and then drift off to the east. So we pretty rarely got impacted directly by thunderstorms. That was one thing that was really unfortunate about working on the summit, is that it always made or break thunderstorms. So you're very rare to actually have a thunderstorm hold together and hit the mountain, or you watch them develop, like this storm here just off to our east, and then go down towards Gray, Maine, and produce a bunch of lightning and thunder. And it's pretty often to watch them go and produce a lot of lightning, but I would prefer if they hit the summit. And then if they came in from the west in the evenings, a lot of times there'd be clouds that would bank up against the mountains, which would prevent any instability from forming. So by the time the thunderstorms made it close to the mountain, they would just dissipate. So it was just always unfortunate. But when they did hit the summit, it was pretty exciting. So this was in the summer of 2017. We actually had a tornado warned storm, previously tornado warned. It wasn't tornado warned at this moment anymore, but it had a really nice shelf cloud coming into the summit that we got to look down at, since the top of the shelf cloud is about 4,000 feet and we were sitting at 6,000 feet. So one of our interns at the time was able to get a time lapse of these thunderstorms rolling in. So during the storm here, we actually didn't have too much lightning, but we did end up with a direct strike to the summit, which is really exciting. That only happens a few times in my time up there, and it's really loud. Sometimes if it's at night, you can see the sparks from where the lightning struck. But sometimes it does cause problems, like we had lightning travel backwards through our ground wire one time and actually fry a bunch of our computers that we had on the summit after lightning struck the building directly. But here's kind of like a ground view of what thunderstorms look like. So I'm hoping that it looks like it's a little laggy on my screen here. So hopefully it's going through properly. But a lot of times we have a lot of wind and rain, kind of acts like a hurricane on the summit. But when we aren't having bad weather, we do have a good view. So this is looking off to the east, where you could actually see the Atlantic Ocean during this morning sunrise as the sun glints off the ocean there. But in the afternoons, it's hard to distinguish it from the land. And then our furthest visibility that we had was off to the west. We can actually see the Adirondacks in New York, with Whiteface being the furthest mountain visible to the naked eye at 129 miles away. So now getting into winter. This was the longest season of the summit, of course, usually lasting from mid-October to mid-May is when we had a snowpack on the ground. So we start seeing accumulating snow, usually sometime between late the last week of October, the first couple weeks of November, and then the snow stays on the ground till mid-May. So what makes it so extreme? We have three factors. I'll get more into detail, but basically terrain, since we are an isolated high peak and very prominent relative to our surroundings, and we are perpendicular to the mean wind. And then during the wintertime, we have increasing winds aloft and then a lowering tropopause that will help accelerate winds in winter, and then storm tracks. We have a lot of the storms that develop in the US will pass over or near the summit at some point. So the terrain influence, we have Mount Washington there in the center of the screen. The orientation of the mountain range is in a northeast direction with our predominant winds largely coming from the west-northwest. So that forces the air to flow up and over the mountain range. And then in the middle of the mountain range itself, there's actually a V-shaped notch in the higher peaks where we have 4,000 foot peaks to the north. And then to the southwest of the summit, we have 4,000 to 5,000 foot peaks. And that helps funnel low-level moisture and enhances upslope snow across the presidential range, which happens to be at the tip of that V-shaped notch. And then winds over the mountain. So like in the summer, one of the reasons we don't experience high winds very often is that you have a very deep atmosphere or tropopause. So the tropopause acts like a lid and prevents air from going above it. So during the summertime, when it's about 40,000 feet thick, it only compresses to about 34,000 feet as it passes over the summit, which doesn't enhance the velocities too much. In the wintertime, the tropopause can drop down to about 10,000 feet, and then it has to go through about a 4,000 foot gap as it passes over the summit. So there is quite a bit more acceleration with that tinier gap relative to the entire depth of the atmosphere. And that's kind of like putting your finger over a garden hose, and the wind has to really accelerate as it passes over the summit. And then last but not least, this was an intern project actually done by Sam Weber, who works at the Salt Lake office now. But we tracked all the closed low pressure systems that passed the United States between 1981 and 2010, and then put a bunch of about 30 best fit lines to all the tracks. So a lot of them pass through New England. And since low pressure systems can be a couple hundred miles wide, a lot of those will have a glancing blow as it goes by the summit. And then probably the most significant reason we see such extreme winds is rapid cyclogenesis. So with the Gulf Stream going up the coast, you have a lot of storms really deepen quickly, which helps enhance the low-level wind speeds. And then Mount Washington's located right there. So we're kind of like on the very western edge of where it's the climatological maximum for some of the strongest storms in the northern hemisphere during the winter season. So with extreme winds, since we are most known for those, the highest wind speed we observed on the summit was 231 miles an hour on April 12, 1934. And it was a global record until 1996 when a gust of 253 miles an hour was recorded in Cyclone Olivia. Our average wind speed, 35 miles an hour, with the highest monthly average of 46 miles an hour. So basically, we'd have a high wind warning for the average wind here in New York. And then my personal record, the highest gust was 142 miles an hour, and the highest experience outside was 137. And we typically see hurricane force winds 1 out of 2 days in winter and 100+ mile an hour days 1 out of 4 days. So these are the anemometers that we use. The pitot tube was our main instrument. The nice thing about the pitot tube is it has no moving parts, and it actually measures the wind by measuring the force of the wind. And then we just correct for atmospheric density, and we get the true value of true wind velocity. And then our other anemometers that we use in the summertime was a regular propeller anemometer, then an ultrasonic anemometer. So we typically try to have at least 2 anemometers going at once for redundancy. And then ice storms. Ice storms can be pretty insane. This was something that I didn't really think much of when I first started at the observatory, but you would just see ridiculous amounts of ice every single year. So our most common type of ice was rime ice, which forms in fog and high winds. And since we're below freezing all the time on the summit and it's always foggy, we spend over 60% of the year in the fog. We see a lot of rime ice basically throughout the entire winter. And a typical day, we get 1 to 3 inches of ice forming per hour. And that's factual. It seems like it's a lot to have 1 to 3 inches of ice per hour, but it does happen on a pretty regular basis. Our instruments are heated that we leave up in winter up to 5,500 watts, but it does not keep up with the ice accretion, especially in like some of the worst ice storms I was up there for, where we were getting up over 12 inches of ice per hour. And then the ice has varying density based off of temperature. So this is the picture you see on the right here is why we don't keep anemometers working, the rotating anemometers in the wintertime, because ice seizes them up and they stop working, and eventually they get torn apart. So this was a glaze ice event. We got about 16 inches of glaze ice fall in this storm, and this is our instrument tower, and then kind of like a zoomed out view, kind of looks like the ships on the Bering Sea. Ended up losing internet with this event since the ice covering our microwave dish was too much and caused it to break. And then there's this measuring it, so that's about a third of ice on the very top of the tower. And then this is more of a typical rime ice event where you get the opaque color of the ice and it grows horizontally into the wind. And rime ice accumulates much faster than glaze ice, so this amount of ice can occur in only about 3 to 6 hours. And then it's not really an ice storm, but one of the challenges we faced in the wintertime was when we had a rain on snow event where you could get like 2 to 3 inches of rain during a nor'easter, and it just waterlogs all the snow and it changes the entire summit basically to an entire sheet of ice. So getting up and down the mountain in the wintertime will require special vehicles to be able to not slip off the mountain. It also led to issues with search and rescues because people hiking may slip on the snowfields that are now covered in ice, and then there's like a long sliding falls. So when there's kind of an elevated alertness, I guess, to radio chats and whatnot when we have a rain on snow event and then a freeze afterwards. And then snow and blizzards. We get 281 inches of snow per year with the highest snow total of 566 inches in the winter of 1968-1969. Then that same year also had our biggest snowstorm with 97 inches from February 2nd to 5th. And then the February 1969 was also the snowiest month at 173 inches of snow falling just that month. And we typically experience blizzard conditions for about 800 hours per year. And that's the way I calculated that when I was doing making statistics for one of our fundraisers, was I just used actively falling snow. So because it was really hard to distinguish from freezing fog and blowing snow what was causing the greatest visibility restrictions. But typically when there's falling snow and high winds, it's the blowing snow will restrict visibility more than fog. So this is getting the precipitation can. I'll speed it up here to go a little faster, but I was filming with my GoPro, and then the education specialist at the time was getting the precip can in the morning, and the door here faces off to the east. So typically snow will build up out in front of the door, and we have to shovel it out and then get out and then carry the can to or swap out the precip cans, which is about a 100-yard walk outside. So sometimes when the blizzard conditions are extreme, we don't get the precip can, because if we can't see more than a couple feet, it's extremely dangerous because you sometimes can't get your way back to the building, because with the high winds, you get really disorientated, everything's white, and it's really easy to go the wrong direction. Once we get out there, it's easy, just pull the second can out and then put the new can in and then just walk back towards the door. To get through all the drifts. which a lot of times those drifts could only form in a few hours when the wind direction changes. So it does not take long to get buried inside the building. So that was like another common task we had to do all winter long, was to be constantly shoveling snow. And then this was a video I took during one of the days where we did not go get the precip can due to the blizzard conditions. It was just the visibility was just too low. That's very easy when conditions like that get disorientated. Then now we're heading into ground blizzards. So these were some of the notable, this was probably the most notable ground blizzard event, where we had winds sustained over 100 for about 12 hours, and it completely scoured all the snow we had on the summit away, leaving us with just ice and rock. So this was looking out our office space down at our snow light. Yeah, so the winds are about sustained at about 100 with gusts to 115 during this video. And then with this video, this was the next morning after the entire night of 100-mile-an-hour winds. This was actually the highest wind speeds I recorded on video, but because the summit doesn't really have much to blow around, it's really hard to actually see the wind. So you can just really just hear it. But this was at 122 miles an hour with gusts to 135. But other than like the noise, it looks like a nice morning. Then this was the wind chart for that storm. So winds are sustained between 115 to 120 miles an hour for almost the entire night, with frequent gusts to almost 140. We peaked out at 137 miles an hour in this event. But to kind of put in perspective, this storm here was another significant storm we had, but it was only gusting to 120, where in the previous one, winds were sustained at 120 for this event. And then we have a lot of frigid cold temperatures. Our average annual temperature is 27 degrees, so spend more time below freezing than not. We typically spend about 280 days per year below freezing on the summit, so not too many days above freezing. The record low, -47, with wind chills regularly falling to 70 below or colder. And then some of my personal records is -40 on the February 13th, 2016, which I believe the day after. That here in Binghamton, what they set a record low, I think at -18. And then my coldest wind chill was -97 on January 6, 2018. We had the air temperature was -37.5 degrees with wind sustained at 107 miles an hour. Ironically, during the -40, the wind chill was only about -80, since the winds were around 40 miles an hour, so pretty light winds for the cold temperatures we were experiencing. So this was actually my first week as a full-time staff working the night shift. And 3 days in, I got to record a temperature down at -40, which it was pretty easy to convert to Celsius for the observation at -40. This was one of the windows facing into the wind that same night. So with how cold it is, it's really hard to retain heat in the building. So you get a lot of frost develop on the walls and windows. Luckily, in the living quarters and the office space, it doesn't look like this, but sections of the building that have less adequate heating, it looks like this almost all winter long. And then in the event where we had the -97-degree wind chills, the temperature inside our office fell to 46 degrees due to it. The cold air contracted the concrete, so there was a lot of wind blowing through all the cracks, and the heaters couldn't keep up with how much heat we were losing the outside. And then here's, of course, doing the boiling water trick to convert it to steam basically instantaneously. Then one more cold weather experiment that we like to do in really cold temperatures. This one's like freezing clothing, so I'll just let it play. Experiment. We're going to take you here, and we're going to try and get the freeze into the wind. All on the outside, current temperature is 22 below zero with our winds less than about 80 miles an hour, gusting it to the mid-90s. So we have wind chills here right around -70 during this event with air temperatures 22 below zero. And then wind speeds around 90 miles an hour. Yeah, so in wind chills this cold, frostbite occurs after 30 seconds. So you have to make sure that everything you're wearing, you have no exposed skin, because you can freeze a pair of pants in about 20 seconds. Oh, that's great. Then probably like the most fun part of the job was de-icing, but it's probably like the most dangerous. So with how much ice we see, a lot of times we're doing this multiple, usually it's every 2 to 3 hours when we have lighter grinding conditions, but in situations where we're seeing greater than 6 inches of ice per hour, we have to go out every 30 minutes to 10 minutes to 30 minutes to get everything off so that the instruments continue to record accurate data. So this night was a night where I didn't sleep well because the winds were really high. So this was a high sustained wind event with 115 mile an hour winds with gusts to 125. And this was a night observer, Caleb Mute, de-icing the instruments. So once you start getting wind speeds that high, we always have 2 people who come out to help out with de-icing just in case something happens. But once those wind speeds are sustained over 110 miles an hour, you can't really stand up in the circle. So you saw what he did. He just kind of stayed crouched down and just hit the metal poles as hard as they can to try to knock ice off. And then my favorite snowstorm or favorite storm while I worked on the summit was one that a lot of people in the Binghamton area will recognize with the March 14th, 2017. The reasons being it snowed a lot, same as here basically, where I think you got the three feet fell here and we got just over 2 feet on the summit. That was what we recorded with the wind speeds. The winds was from the east, which is pretty rare. We typically have west winds, so it posed a unique challenge, and the building's built to handle west winds. So when you have an east wind, it's blowing right out all the doors, which makes you think that all the doors are going to break and blow open. But the peak wind gust was 138, and with the gust, your ears would pop. And it was the first storm working on the summit where I felt the building shaking in the wind. which the building is 2 feet thick steel reinforced concrete with bulletproof windows. And the fact that it was shaking in the wind is like pretty remarkable. And then extreme cold. The day prior, we had a low of -35 degrees, and then it warmed up with that warm front coming through to, I think, right around 20 degrees, and then it fell back to -11 just after the storm. So starting off, looking at blizzard conditions from the main windows in the rotunda. And then towards the mid-afternoon, we started having, like, I was worried that we were going to have the doors start to blow open from the wind, but yeah, so it's extremely loud because there's not as much insulation on the east side of the building either. And then one final one before the storm started to calm down. So in this storm, it's actually really difficult to get the de-ice because the ladder to get up to the top of the tower faced east. So once you got halfway up the ladder, you're being completely exposed to the wind. So it was really hard you'd lose your balance. And if you got blown away from the ladder, it's hard to get back. So we didn't really do much de-icing during this storm. But this was what the wind chart ended up looking like with the peak wind gusts from 138 and winds sustained over at 100 miles an hour for 2 hours in a row with these numbers here. So that's the hourly average and then hourly average wind direction. And then April 16th, 2019 was my day with both my personal records. This day we had ice accumulation at over 12 inches per hour. I did not get any video because it was probably one of the most stressful nights since we were de-icing every like 10 to 15 minutes. And within 5 minutes of de-icing, the wind would drop off, then you de-ice it, go back up to where it is, and then drop off again. So there would be times where you'd hear this huge wind gust hit the building and it wouldn't be recorded. But this was the gust that I was outside up on the tower for when we hit 137 miles an hour. And then later that evening, we hit 142 miles an hour. And I believe the night observer might have been on the summit during that event. And then finally, it's like with the conditions, like how do you get up and down the mountain? We use a snowcat. So we owned a snowcat, and then the state park, since they also occupied the building year round, also had a snowcat. And so on the right side here is the Mount Washington Observatory snowcat, and then the left side is the state parks. Why we have a white snowcat when we deal with whiteout conditions, I'm not sure, and it has actually led to problems with people getting outside to go look around in the blizzard and then not finding the snowcat walking back towards it because it's white. So the next time we get a snowcat, I think they're going to paint it yellow or something that's much more visible. But some days doing shift change was marvelous, where we're just after a fresh snow, perfectly blue skies, and it was just like a really fun trip up. But most of the time, we're not so lucky. This is more of a typical shift change where visibility is only a few feet, and it takes 3 to 6 hours to go the 8 miles up to the summit, especially when conditions are this bad. A lot of times you have to stop and wait for the winds to calm down slightly, then you can see the road and you could inch forward for a little bit, and then the winds pick up and the visibility drops back to 0 and they have to wait. Or if there's a situation where a search and rescue is required, then we have to get up to the summit, we'll do dope in a rope, where people tie themselves, one person ties 25-foot rope to one side of the blade with another person to a 25-foot rope on the other side of the blade. And you go forward until you can find each side of the road. And then the snowcat will inch its way up to where you are, and then you find the next 25 feet. So you literally just inch your way up through blizzard conditions. If there is a search and rescue or there's a reason that there could be lives in danger, then typically we try to push through really bad weather. And then when there's not enough snow to go up and down the mountain in the snowcat, since it requires at least 6 inches of snow across the entire roadway, we take a truck and van, of course using chains, but it's always kind of sketchy because you're going up over lots of ice in a vehicle with chains on, with a cliff on one side. So it couldn't be nerve-wracking, but we did it all the time. And the drivers that we had were skilled and really never really worried at any point. Only during the summer months we had to worry a bit more. So during the summer you can go up and down as normal, but with a lot of with it being open to the public, every once in a while you run into situations like this where someone drives on the incoming side because they're afraid to be near the edge of the road, and that leads to more issues. And most of the car accidents occurred with like any of the observatory staff or state park staff or on-road staff occurred with basically someone being this way and not moving over far enough, and then there's a collision or whatnot. And then the funnest way to get off the mountain is skiing. So every now and then you get the perfect snowstorm and you get permission from the auto road, who technically owns the road, so it's a private road, to ski down. So it's not allowed, but if they're nice and having it and they're having a nice day or a good day, and then you ask them, hey, can I ski down the road for a shift change? And they might say yes. So that was always really fun to be able to ski off the mountain because you get back to your car in a much shorter period of time. Then kind of like the last thing to talk about is the snow wall. So once the accumulating snow season's over, the auto road starts to plow the snow. So throughout the entire winter, the snowcats drive up and over the snow rather than plowing it. And then during the spring, all the snow gets cleared off the road, so you get the snow wall. So this was my first year where we actually had a snow wall, because my first winter was actually a dud of a year. It was a 2015, 2016 winter where we didn't get much snow at all. Most of it was rain events. So this was 2016, that's spring of 2017, where there was about 12 feet of snow, and that's looking from the snowcat looking down to see how far the snow wall goes. The reason this exists is above tree line, the wind scours all the snow off, and then right at tree line from about 4,000 feet to 5,000 feet in elevation on the mountain, you would get an insane amount of snow accumulations, because that's the first area of friction and the snow will be deposited there. And then last year, in 2019, was probably the biggest snow wall that we end up getting, because even though this wasn't a very snowy winter, we only had 30 hours the entire winter season with temperatures above freezing, so we had no melting events. So basically all the snow we had from November to April, when this picture was taken, was still on the mountain. So there's me and my coworkers standing underneath it. So we end up with about 20 feet of snow with this snow wall. And then just kind of go into random pictures of other happenings that occurred on the summit. So this is my poor attempt at taking pictures of the Northern Lights, which occurred probably about a dozen times per year, but we're not always in the clear. But luckily, one of my coworkers, they are much better at taking pictures than I am, and they're basically a professional photographer. So this was like the same aurora, where with the cell phone it's kind of lackluster, but with an actual camera you actually see all the pillars and the lights and everything. On rare circumstances, you had a snowfall with no wind on the summit. So we got about 6 inches of snow here, and this actually occurred in May. So this was mid-May when this had happened, and that's more common, is to have snowless or windless snows in the springtime, when you get early season convection and it just forms over the summit, and you get just a stationary snowstorm right on the summit for a couple hours. And then getting out for exercise in the winter can always be a challenge. So some days where you have clear skies but maybe still high winds, I'll go for a hike up and down the auto road. But this was a cool shot of a lot of the blowing snow we were having, along with lenticular clouds forming below the summit. Then damage does occur. So we lost our internet one day, actually with that same event with the blizzard that I showed you where we had the 12 hours of winds sustained over 100. We lost our internet for a while, and at least it was pretty easy to troubleshoot this. But it was really cool, neat to see it actually break the hardware. Usually it breaks the wood that we screwed into, but this actually sheared off the bolt that was holding the pole in place for the microwave, the internet connection. And then another unique thing that occurs on the summit is flooding. Even though we're like the highest point in the Northeast, during rain on snow events, the really cold snow will freeze the liquid water. So you kind of get all the rain that is falling will run over the top of the snowpack. And then with the way the snow drifts around the building, it kind of acts like a dam. So the water will just kind of fill up as a reservoir and then start flowing into the building. So we had to deal with flooding a lot. And then you can see our flamethrower on the bench on the side, and that was actually used to melt our way out of the buildings, because with the ice storms, sometimes all the doors freeze shut and they have to have a way to get out. So the flamethrower is used to melt all the ice off the doors and the frames, so that way the door will open. And then just random snow pictures. So this was a picture after an upslope snow event where we had 4 days of snow, and we ended up recording 40 inches of snow those 4 days. But it's just pretty neat to see that most of the rocks that we had on some of the other mountains were completely buried by the snow. And then the famous Tuckerman's Ravine. This was the downwind of the summit from the prominent wind direction. So this was the most likely area for snow to accumulate, and it was a big bowl, big glacial cirque that was on the eastern side of the mountain range that can fill with snow. In fact, some of the snow measurements from the base of the bowl here can exceed 900 inches of snow. So the snow, this would be the last place snow would melt, and a lot of times it lasted till late July and early August. And then, of course, a lot of people want to know about the cat. So this is Marty the cat observing precip. And he's a black Maine Coon and has lived on the summit for 8 years. Cats have been a part of the observatory since started in 1932, originally for rodent control, but as better building codes have come around, their buildings aren't as susceptible to rodents. So now it's just there for, he's just there for tradition. So Louis is in our gift shop, making sure, doing some quality control there. But yeah, that's my slideshow. So I can open up for any questions. Feel free to type them out and I can answer them to the best of my ability. Yeah, I'll just leave up some of like the means and extremes page here, just so you can see some of the other records while I wait for any questions. Let's see here. Looks like I'm getting some. Let me read through them. All right, so does weather on the mountain impact the East Coast, the weather on the East Coast? And it actually does have a pretty good impact. A lot of the times as we have the wind flow up and over the mountain range, you can get mountain waves that will generate precipitation or clearing downwind of the summit. Other aspects is flooding. So the terrain can block weather if you have an east or southeast wind coming off the coast and create a heavy rainfall event on the east side, which has led to flooding events in the recent past, as well as when you do have those rain on snow events, then if you do have them last for more than a few hours, that can melt the snow plus the falling rain, and you can get really high rivers in a very short period of time. So it is really nice to have a point of observation at the headwaters. So it's really great for hydrology. All right, let's see. How is it in, let's see. All right, so how was it encountering people at random time, and has anyone showed up desperate for help? That happens a lot. It actually happens way more often in the summertime, where it is open to the public. So a lot of times people will hike up after dark thinking the building's still open, or expecting to be able to have one of their significant others or one of their friends drive up to the mountain and drive them off. But when it's like 9 o'clock at night and they're tired and not prepared, they a lot of times are knocking on the door. And the state park does keep EMTs up on the summit at all times. So a lot of times they are physically assessed to make sure that they're okay, there's nothing significant. But if they are fine, they have to hike down the road. So if they don't have a flashlight, a lot of times there's like $1 dollar store flashlights that they're given, and then given a map on how to walk down the road. But if there is a situation where they're hypothermic or injured, which happens a lot in the wintertime, where typically if someone knocks on the door in the wintertime, they're more prepared. And if they're knocking on the door, then that usually means something's gone wrong. All right, like there's times where people had broken arms knocking on the door, really bad frostbite on their face because they weren't wearing a face covering and extreme wind chills. So in those situations, we usually bring them inside, try to warm them up the best of our ability, and then start the 12-hour process of getting them off the mountain. So unfortunately, it takes a really long time to get people down. Let's see. So what do we do for food if we can't get off the mountain? We have a large supply. So we have a huge chest freezer on the summit, and then a lot of canned goods. So we have about 3 months worth of food when I worked up there at any given time. But you did run out of fresh food pretty fast. So every once in a while, you'll have the food will freeze and the snow count on its way up. So all the fresh food is ruined, especially like the fresh fruit and vegetables ruined before it even gets to the top. So then you have to have canned food the entire week. So that does happen a lot. Let's see. Yeah, that's chasing hikers off after dark still happens to this day. Let's see, wildlife. So what wildlife is in the area? We didn't have too much in the way of wildlife on the summit. It was largely just small rodents. We did have pine martens on the summit, but the biggest mammal I saw was a fox. So we sometimes would have a fox visit the summit in the summertime, but in the wintertime, you mainly just had ravens and birds. You didn't even have really any rodents or anything like that. You only had to deal with mice and whatnot for a pretty short period of time in late October, early November, when it really started to cool off. But we did have a moose on the summit once. But that was in the 1980s. So that's pretty rare to have large animals make it up to the top. And let's see. All right, so that's all the questions for now. I'll wait a few more minutes before I end the session here, since we've only got a couple more minutes left of the hour here. Yeah, but I guess I go on with like how long was my internship? So I did a 6-month internship actually at the summit. So I did the fall and winter seasons. So right after I graduated from the University of North Dakota, I got the fall internship at the observatory, and then did that for about 6 months. And then after 6 months, a job position opened up on the summit, and I applied for it and was luckily able to get it. And then I worked up there ever since until I moved here in January. All right, so that's about it that I have from me. Thanks a lot for everyone who joined, and hope you learned something and got something out of it. I hope the videos went through well. So thanks a lot for joining, and have a great evening, everyone.